Hello, welcome you all the viewers in this session. In this session I will discuss about multi-threading in Java. Myself MP Misra, faculty SOCIS. In this session I will try to brief you about what actually multi-threading is, how multi-threading can be implemented in Java, and how your program can be multi-threaded by using different methods and different techniques available in Java. So let me see the contents of discussion which we will cover in this particular session. In this session we will try to cover what is thread, then we will try to explore something about what actually multi-threading is and what is the requirement of multi-threading. And then we will discuss about how Java use threads, means how threads can be created in Java, and then we will discuss about if you are creating a thread, how you can give a specific name to that particular thread, and then we will discuss about different priorities which can be assigned to different threads in the execution in the program, and then we will discuss about some basic methods which are used for multi-threaded programming in Java. So let me start our discussion with threads. If somebody asks to you what actually thread is, in programming term you can say that thread is a separate stream of execution that take place simultaneously with and independently of everything that else might be happening there. Means if there is a program, that program is running, there is an opportunity or there is a chance that so many things or multiple things are happening in a program, and if those multiple things may happen independently or joined to each other, then you can say there are multiple threads which are running in the program. A thread is like a classic program that starts at a particular point and then it goes to end of the program. Means every thread is having its own start point, and then after performing certain operation whatsoever associated with that thread comes to end and the thread expires or ends. Without thread, the whole program, means if a single program you have written and you are saying that there is no independent activity going on, all the things are being handled in a single program only, so you can consider that that particular program is a single threaded only one thread is there, not more than one independent processes or programs in execution. If I am saying processes or programs, this should not be taken in full-fledged meaning of processes and program. Inside a program, if independent components are there and those components may run independently, then those components will be called as thread. If there is no thread, then in that situation CPU will be allocated to a program and the whole program will run. If inside that program some activity is happening and that activity is taking very large amount of time, for example you are in an infinite loop, then in that situation your infinite loop will keep on running, means you will be for whole the time in the infinite loop and you will not come out of that infinite loop and you can't perform any other operation, and it may be that on the basis of some other operation that loop which is running infinitely may get certain situation from get exit from that infinite loop situation. So what you need is that you need your program to be looked as several independent components inside the program, and all those components sooner or later gets their turn to perform the operation, and on the basis of the operation of those components whole program is displaying its characteristics. For example, if I take a situation in real life that you are waiting for somebody, and if that person will come then only you will go out of the loop, but there is a condition that if you go out of the loop then only that person will exit, that person will get entry into the room, then there is a situation that you will keep on waiting and that person will never come into the room. So what you need is to test the situation that you have to come out of the loop or out of the room, and you have to provide entry to another person to get into room. So that particular situation also can be visualized as that single CPU you are having and you have to perform the operations, then that single CPU is being allocated for one program only, and in that case some other operations will not get their chance. With threaded, or if you are having more than one threads in the program, the other tasks that don't get stuck in the loop can continue processing without waiting for the stuck task to finish. So let your loop run, but at the same time what you are doing, that you are keeping that particular loop apart and then you are performing some other operation. So your operation inside the loop is being executed. It maybe it will be getting delayed because you have to provide chance to other options or other operations in your program also to perform. So if you are giving chance to other operation, in spite of just keep on waiting that inside the loop let the things finish, then I will go to another sequence or another step in the program and execute. What you are doing is you are suspending the current loop operation and you are coming out of that loop and you are performing some other operation. In this way you are giving turn, or you are giving a chance to each section which can run independently in the program sooner or later. Further you can say that implementing thread is harder than implementing multitasking in operating system. So one more issue we are addressing here, that how multithreading can be implemented. What are the different issues involved in multithreading? If we are saying multitasking means there are independent tasks and they are in a queue and they are getting their chance. But when we are saying multi-threading, what we are looking is actually inside a single program you are having independent component that may execute separately and concurrently. So the major challenge in multi-threaded programming is that how you will identify different threads in your program, and if you are identifying threads, how those threads will take care of the internal resources available in the system to perform the operation, and if certain concurrent operations to be performed, if some read-write operations are going to be performed on the same data concurrently, how you will handle that particular situation. So those all things must be addressed during designing of a program which is going to use multi-threaded concept. And further you can say threaded environment provided in Java allows a thread to put locks on shared resources, that while one thread is using data, no other thread can touch that data. That particular is the concept of synchronization. What actually you are going to do in a situation when one data is being accessed by a particular thread, another thread should not access that data if that data may change its state. Means if one data is being read by more than one thread, there is no problem at all. But there will be a problem if one data is being read by a thread, at the same time that same data is being modified by another thread. So there may be ambiguous situation that one thread is looking on the data and the meanwhile another thread is making change on the data. So there is a chance that you will not get either up-to-date data, or you will get data that particular is not needed for the thread which is reading the data. And next you can say in multi-threading is that the proper choice of object method to synchronize is one of the more difficult thing to learn about threaded environment. As I said, data, so basically our primitive data cannot go under synchronized class. So if you have to put something under synchronized, that should be a object. Inside that object you may access its member variable or state data, but independent primitive data cannot be synchronized. So this synchronize can be applied only on object in Java. Now let me see how Java uses multi-threading, means how you can create thread in Java. Basically in Java you can create thread by two ways. One is using thread class and other is by using a interface that is having only one method, that is runnable interface. So, but let me see what applications developed in Java use multi-threading extensively, or in another term you can say all the Java programs are having some internal threads also, and those internal threads take care of the system's requirement or the system's resource allocation to the different chunks of the program sections. So, if you see application developed in Java program, you can say that applications and applets both use multi-threading. Next you can say running environment starts execution program with the main method in one thread. Next, garbage collection takes place in another thread. Just I am counting that there may be more than one thread in a single program, even if you are not creating threads in your program independently or separately. Even if your program is single threaded or only main thread is in execution, there are some hidden threads or background threads which are performing operation for your program. One is the main thread that is performing your operation in single threaded programming or without any thread creation program. Garbage collection is there that keeps on running, and that particular is handled by a separate thread. Screen updating occurs in another thread, and there may be other threads running as well, mostly related to behaviors of applet viewers or web browsers. Now, let me put one example here. If you are using a website in that more than one user is accessing a particular resource or using a particular application, how those different users will be handled by the system. For example, if you have to connect database and you have to connect database for different users or for so many users at once or concurrently, in that situation multi-threading is one of the good option to perform concurrent operation or to provide concurrent connections or provide concurrent database connections to different users which can perform concurrent operation. So, there is a chance that multiple threads are running simultaneously in a very big application, in that different users are getting their turn. Whenever you log on in your system, you are getting a different instance of the resource and you are performing the operation, and that different instance of the resource or a object of the resource you are getting with the help of multi-threading means one more thread has been created for you and you are using the application as a client. And maybe there are so many clients using that particular application concurrently with the help of the concept of multi-threaded programming. Now, network applications are extremely threaded. So, whenever you are developing network application using Java, there is a chance that you will come to a situation where you have to use multi-threading, and there may be a very basic step required to you to provide connection to different user, and that particular can be handled by providing different threads to different user in the application. Now, let me see thread class. As I discussed that there are two ways to create threads in Java. One is that by implementing thread class, extending thread class and implementing runnable interface. Now, this is the class Java language.thread. So, for thread creation we will see very soon in our examples that we are not importing anything. The thread class is by default available to you because java.language.star is automatically imported in every Java program. Second is by using Java language runnable interface. This particular interface is having one method, that is public void run. Inside the run you can provide whatsoever operation you have to perform for your thread, and that particular instance of the runnable interface you can provide to your thread, provide to create a thread. Now, thread class has three main methods. These methods are start, run and stop. And start method prepare a thread to run. In fact, start method, if you are invoking on a thread, you are not going to start the run the execution immediately. Actually, start methods make your thread ready for running. Whenever the thread scheduler will provide the opportunity to this particular thread to run, this thread is ready to run by invoking that thread.start method. Now, the run method automatically performs the work of the thread. So, see, this run method you do not have to invoke. Basically, when you are invoking start method, whenever the thread scheduler will provide the opportunity or the chance to thread to execute, the thread will automatically invoke this run method, and whatsoever you have implemented inside the run method will be executed as a result of execution of your thread. Now, in addition to these start and run method, there are some other methods also. These methods are extensively used in multi-threaded programming: suspend, resume, sleep and wake up. In our discussion, we will see what sleep method is and how sleep method can be used in multi-threaded programming by an example. Now, let me see next one, that is runnable interface. This interface allows you to add threading to a class which due to any reason cannot conveniently extend thread, or it don't want to extend thread class. Now, you may ask one question, that there are two ways to create a thread. One is by using thread class, another way is by using runnable interface. If you are using thread class, you have to extend the thread class by your class in which you are creating thread or for which you are creating thread. And second, runnable interface. If you are implementing runnable interface, the only method of the runnable interface run you have to implement, but the thread class also has implemented this runnable interface internally. So, whenever you are extending this thread class, this run method is default implementation is there automatically, and that default implementation basically don't perform any operation. But whenever you create a thread and you just simply write thread.star or the thread object.start, it will perform the operation, but it will not execute or it will not do anything, because this run is not having any operation to perform. Default implementation of the run is there in the basic thread class. Now, let me see some example through which we can create threads by using these two methods. So, here basic examples I will explore, and then I will try to show you that how actually thread is created and how the result is coming after performing the operation which we are showing here. So, see, in this thread test class, we are not creating any thread by either by extending thread class or by implementing runnable interface. What we are doing is just we are checking whether without creating any thread in our program, is there any thread actually running. As I mentioned that even if you don't create any thread, there is a main thread which is running, and that particular main thread is taking care of the execution of the whole program. So, this current thread is a method in the thread class, and this current thread return the object or thread object which is currently running. So, we have not created any thread object, but this T will get something, and if this T is getting something, what we are trying here is system out dot println in this current thread plus T. Just we are trying to verify whether T has been given certain value from thread dot current thread or not. If it has given certain value, then what actually that value is. After that, what we are doing, t dot set name. If t is a thread which is running without creation, or automatically it is created by the system and it is running, then that will be printed here. And after that what we are trying is that if t is a thread and it is running, let me change the name of the t. So the name of the t we are changing by my thread. Now whatever name earlier was, that particular will be changed by my thread, and after changing again we are printing this t object. Now after that we are printing certain value. This value don't have to do anything with the test, it is just for fun you can say, or it is just for visualizing that your execution is doing operation sequentially. Then once again we have use here thread dot sleep method. This sleep method basically stops execution of the thread for this millisecond. Here we have given 1000 millisecond, that means for 1 second execution will be stopped. After 1 second once again the execution of the thread will start and it will perform the operation. So what actual operation you are performing inside this loop? You are performing a print operation that is going to print I equal to 10 to 1, but after each printing, means after each system.out.println I statement, what you are doing is you are going for a sleep, means your thread is going for a sleep. So once you print 10, you will find a pause for a second, then you print 9, you will get a pause for a second, then you print 8. In this way the loop execute, but inside the loop you are having a sleep method. So your thread will go for the sleep for this specified time, and the specified time we have given here is 1 second. So for performing the operation for 1 second, the thread will go for a sleep, then it will perform the next iteration and it will go for a sleep. So what you will find 10, then there is a stoppage for 1 second, then you will get 9, then you will get 8, and in between each display of the number you will get a pause for 1 second. So now let me see the output. If you run this particular thread program, what you will get, current thread is main and then 5 and then main. This main is the name of the thread. Now after changing the name of your t object what we have created here, you are changing the name here, so that change is reflected here, my thread. As I mentioned that after this you will get 10, then 9, then 8, then 7, but in execution of your program at runtime what you will get is 10 will be displayed, then pause, then 9 will be displayed, then pause. In this way you will find the result of your this program, where you will find that really there is a thread which is running and the name of that particular thread is main. This thread we have not created at all, this is created by the Java runtime environment or Java runtime system itself. JVM has created it, and the name of that particular thread we have changed with the help of the set name method. So this thread class is having one method, set name. This particular method can be invoked on any thread and that particular thread will change its name. Now let me see another example. In this example we are going to create our own thread, and our own thread is created by implementing runnable interface. As I mentioned that if you are implementing runnable interface, what you have to do is you have to implement this particular method, because this runnable interface is having only one method and that method is public void run. Now see, thread t is the object of thread class. Now thread test is constructor of our thread test class. In this what we are doing is, in this constructor we are assigning one object. In fact, this particular is the declaration of the object. This particular is currently pointing to null, and now this particular object reference T will point to thread object created by thread, this daemon thread. So we have created a thread here, demo thread, name we have given, this is the reference for this particular thread test only, and then we are printing child thread T. Now T dot start. This T is a thread created. Now T dot start, if we are doing this, T dot start will automatically invoke your run method whenever this T or this thread will get a chance from thread manager. Now once again inside this, what we are doing is child thread I, and then child is exiting after performing some operation. So this implementation is there. Then we are having another class, in that our main method is there. Thread, new thread test we have created in test 1. This new thread test is an object. When you are creating new thread test, you have to remember that this particular constructor will be called from this point, and if you are calling this constructor, what you are going to do is you are going to create a thread object, and after performing this creation you are going to display something, and then you are going to call start method on this thread object. Now let me see the output of this program. See, you have created a thread, then for I equal to 2 to 1, system out println I, and then system out println main thread exiting. Now if I say this particular loop is simply for testing that you are inside the main method and you are printing something, because now you are having two threads in your program. One is the thread created by thread test object, and other is the main thread which is by default created by the JVM. So main thread will also keep on running. At the same time, your new thread test created thread object also will run, and what result you will get is main thread 1, 2 is printed, then 1 is printed, and then main thread exiting. Means your main thread is getting completed before your child thread, that is the thread object created by thread test, is exiting. Then what you are having is 3, 2, 1. Now let me see, if this main thread 2, 1, we see this particular loop is performing the operation. This particular loop is under control of main thread, and this particular loop is under control of the thread created here. So you will get this particular object created, and this particular is the demo thread, and the 5 is the priority that we will see in next section of our discussion in this session. And then let me see the second way of creation of the thread. That particular is extends thread class. My thread extends thread. One thing you can say here, that there must be a space between these two. This extends. Now this thread is constructor of thread class. In this, what you are providing is a string. So you can ask one question here, that how many constructors are there for thread class? The answer is there are two constructors for thread class. One takes a string as input and other takes object of type runnable or reference of runnable interface. Now here we are creating one thread by using this extends property or inheriting from thread class, and this constructor my thread. If you see in this constructor we are passing one string and then once again we are calling super name. So as you know that inside any constructor, if you are having super call in that particular constructor, it calls the constructor of its parent class. So the parent class of my thread class is thread. So it will call constructor of thread class. Which constructor it will call? It will call this constructor which is taking string as input. Then we are having here while run. Inside this what we are printing is this dot get name. Now if you see this get name method, this get name will display the name of what? It will display the name of the thread which we have created by your my thread constructor. So whatsoever you are passing in this my thread as argument, that particular will be the name of the thread, and that will be returned by this dot get name method. Now thread priority. If you are having in your program multiple threads and they are running independently, but at the same time you need that certain threads must get some more chance to execute, or some threads should be given more priority to execute than other threads, and this situation arises in the situation such as if threads that interact with the user should be given more priority or should be given higher priority, and if some threads are handling calculations in the background should be given low priority. For example, if you are having an application developed, in that application you are interacting with the client, at the same time you are updating the database. So your updating the database should be given lower priority. Whenever a client request is there, you should give that particular operation more priority. And if you are using multi-threaded concept and two threads are responsible for handling the update operation and the client handling, the thread which is responsible for client handling should be given more priority. Now in Java, thread priority varies from 1 to 10, and there are 3 constants also. Those 3 constants may be used in your program to assign the priority, and these 3 constants are thread.max priority, and this max priority takes value 10, and there is the second constant, that particular is thread.min priority. Min priority, this particular takes value 1, and the third one is thread.norm priority, that particular takes value 5. Means these 3 constants are of value 10, 1 and 5. If you remember earlier in example 1, when we were displaying the current thread object, we have seen that it was written main, then comma, then 5, then main. So one main in this particular represent the name, 5 represent the priority, and second main represents the group to which this particular thread belongs to. So main thread created in Java program, which is created by the JVM, is having by default norm priority, that is 5. That's why that 5 is displayed there. Now if we test this particular program, you can go through this program and see we have created 3 threads, RAM, Mohan and Ravi, and we are starting these three. So we have, before starting, we have set priorities of these three threads by using set priority method of thread class, which is used for setting the priority of the threads. So Ram has been set with the min priority, Mohan has been set with the non priority, and Ravi has been set with the max priority. So you can easily conclude that if you run this particular program, the thread Ram will be executed in the last, means the Ram will be the last thread to be finished, Mohan will be the second last thread to be finished, and Ravi will be the very first thread to finish, because the priority of the Ravi thread is maximum, that is 10, and it is more than any other thread in this program. So in this way priority can be assigned to different threads, and these priority assignment can be done on the basis of the importance of the different threads running in the program, and these priority may be during the program or during execution of the program also change. For example, if you are executing a program and in that program there are certain load associated with that program, but you have defined a rule, or there is a rule set that if this particular thread is reduced by this much load, or the load is less than the specified load, then priority should be decreased by 1. Then what you have to do is you have to keep on checking the load associated with that particular thread, and if the load decreased to the level which is required, then you have to invoke this thread dot set priority method, and then you have to assign the priority which is specified there. Now let me see some more methods which are used for multi-threaded programming. Sleep is one of them. As we have seen in our earlier example, that sleep method we have invoked on the thread object, this object dot sleep dot time in millisecond we have given. Now one more thing what you have to take care here is that this sleep method throws interrupted exception. So wherever you are calling this sleep method, you have to catch this interrupted exception like this. Sleep method you are invoking inside a try block, and then you are catching the exception which is thrown. This is interrupted exception, and you are catching here this interrupted exception. Now let me see one more example how sleep method is used, and you have to guess what output this particular program will give. This is the program for testing sleep method. My thread, we are extending thread class, then we are implementing this run method. Inside run what we are calling is sleep. Sleep method is called on thread created by my thread class. Now this sleep is going for sleep for how long time? It is going for sleep for 20 seconds. Now as I mentioned that if you are invoking sleep, your sleep should be inside a try catch block, and that particular must handle a interrupted exception that is thrown by this sleep method. Now I have created one object A1. This A1 is object of type my thread, and this particular will be object of thread because my thread is extending thread class. So now A1 is a thread. If you call A1 dot start, whenever it will get a chance to be executed, means whenever the thread manager will give a chance to A1 to execute or run, it will go to run, and inside run it will go, when it will go, it will sleep for 20 seconds and then it will come out of that, and then your system out will print something. Now my question is, what are the possible result of attempting to compile and run this program? The question is very simple, that you are trying to get start time here and you are trying to get stop time here, because this current time is the time in millisecond, and this millisecond time is being returned by the system on the basis of the current time of the system. Now one more question arises here, whether this A1 dot start will get a chance before we come to this system dot out dot println or print method. If the system dot out dot print method is being executed before thread A1 get a chance to run, then definitely it may print something between 0 to some value, because this particular belong to main thread and my thread A1 may not be executing at that time when this particular is being displayed, and if it is being executing on that time, so it will go for a sleep for this particular period, and after coming out of sleep it will give chance to main to execute, and then this time will get a difference of 20 seconds. But if it is not executed and main thread has performed this particular operation, then there may be some other value which will be displayed. So it may vary from 0 to 20 seconds. And let me see some more methods which are available in thread class. Is alive, this particular is used for checking whether a thread is still running or not. Suspended, for temporarily halt of a thread. Resume, this particular method is picked up execution of the thread where it is left. Means if you have suspended, and from suspended if you are resuming, then the operation of that particular thread will be resumed from the point where actually the suspended was invoked. These two are the final methods, means they cannot be overridden in the subclass. Thread dot. Now let me see or wrap up our discussion. Some things are there which we discuss, and those things to be remembered, and these things are: thread dot start method causes a new thread to get ready to run at discretion of the thread scheduler. Now runnable interface declares run method, and this run method is public. The thread class implements the runnable interface internally. That's why whenever you are extending thread class, runnable interface is implemented in the thread, and a program will terminate only when all the threads stops running. So this is the basic discussion. During this discussion, what we actually tried to cover is that what is a thread, how threads can be created in Java, and how threads can be assigned different priorities. What is the sleep method? If a thread is going in sleep, what the effect of that particular will come on the program. So with this, I hope you may create simple multi-threaded program in Java, and you can try some exercises based on our discussion.